Hello everyone, my name is Haider and today I will show you how to use the 3D slicer. I have already downloaded some image slices for a human heart or CTA cardio, as you can see here. So I'm gonna load them. Next, we use this tool, which is the editor, to select the slices that we want. Then we can select or customize the coloring. Next, I'm gonna select here the level tracing effect. There are other tools for drawing your selection, but I like this one because it can, as you can see here, you can select the whole object and then you can scroll through the slices to select basically the same object in all the slices, as you can see here. Now you have to move the mouse a little bit to get a better, scope of the selection. For this tool memorizes the selection for the previous slide, so you have to move the mouse a little bit in order to adjust it to the new size. As you can see, the heart is, when I'm scrolling through the slices, the heart is getting smaller, and you can see here. So I'm gonna select couple of slices, and don't worry if you make some mistakes. You can always move the mouse to select a bigger region, as you can see here. Now my selections are not very accurate, but you get the point. And after I'm done with a number of selections, I can go ahead and select this make model effect, which will create the 3D model, and then click apply and wait for some time, and there we go. This is our 3D model for the slices that we have selected. Now the second part of this assignment is to do optimization between two robots. I have created a GUI for this task. This is the GUI. So as you can see here, there is an area for plotting and a button to create the robots. I have created two Puma 560 robots and named them Robot 1 and Robot 2. I already know the correct transformation matrix between those two. The distance is 1.2 millimeters, and Robot 2 is rotated around the z-axis by minus pi. And here I can move the robots. As you can see, I can move Robot 1 on the X and Y and Z coordinates. And as you can see, I'm also plotting the position of the end effector here. As for Robot 2, we can use the sliders to move it. And once we get into a position where both robots match, let's try to match their coordinates here. So I'm rotating the end effector of Robot 2 in order to match that of Robot 1 perfectly, as you can see here. And I can click this save data, which is gonna save my data into a data file, as you can see here. This is the data file. These are the XYZ coordinates for both robots. This is for robot 1 and this one is for robot 2. You can see the values match. And let's try to move this robot. As you can see, the inverse kinematics function takes a while to load the new coordinates for the end effector. And I'll move robot 1 as well. Now, for demonstration purpose, I have already created a data file for about 8 points where both robots meet perfectly. So let's rotate this one. And I'm sorry, it should be this way. And this one is supposed to go this way. As you can see here, they are almost matching, and once we save the data, it's gonna be saved to the data file. As you can see here, the new coordinates. Now, I've already, as I said, I've already created a data2.txt, which is used by the objective function here to do the fmin search for optimization. As you can see here, I'm inputting the disturbed the XYZ yaw pitch roll for the transformation between the two robots. I already know the real transformation, so I'm gonna go ahead and optimize it, and you can see I'm getting an optimization that is pretty close to the real transformation, which I can show you here. So as you can see in my code, the transformation that I have created is this, which is a translation 1.200. As you can see here, we have 1.2002, which is very close. And then these are 0. They are very, very small values until the rotation about the z-axis, which is the roll, is minus 3.14, which is basically minus pi. And the reason for this difference is that the points are not perfectly matched, and we are just observing them by the eye, so that's why there is a difference between the optimized transformation and the real transformation that we have created. Okay, thank you all for watching, and stay tuned for more videos.